Hello all. I welcome you all to this subject process planning and cost estimation. So I am Dr. Muhammad Iqbal, professor in the Department of Mechanical Engineering, SRMIST Katangulutur. So in this lecture, we are going to discuss the fundamentals of process planning and cost estimation, particularly the introduction to process planning and the various steps involved. So process planning acts as a bridge between product design and manufacturing. So by the end of this lecture, you will be understanding what manufacturing is, the difference between manufacturing and production, who performs process planning, and the major steps involved in developing an efficient manufacturing process plan. So coming to the manufacturing. So manufacturing originates from the Latin words manus, meaning hand, and factus, meaning to make. So manufacturing is the process of converting raw materials into useful products by utilizing machinery, tools, power and human labor. So during manufacturing, some materials is inevitably lost as scrap or waste. The primary objective is to add value to raw materials and transform them into products that satisfy customer requirements. Coming to production, production is a broader concept than manufacturing. So it refers to transforming resources into outputs, which can either be goods or services. Production may or may not involve machinery. Human labor alone can sometimes produce outputs, especially in service industries. So therefore, while manufacturing always produces physical goods, production includes both tangible products and intangible services. Coming to the differences between the manufacturing versus production, so it is important to distinguish between these two. Manufacturing always requires materials, machinery and labor to create tangible goods, whereas production can involve only labor and can generate both goods and services. So every manufacturing activity is a form of production, but not every production activity is manufacturing. For example, producing bakery products or fabricating a turbine is manufacturing because raw materials are transformed into new products. So coming to the examples of manufacturing and production, so let us consider the baking bread involves converting ingredients into a finished products, which is manufacturing. Similarly, producing a turbine involves multiple manufacturing process. In contrast, assembling pre-manufactured engine components is considered production because it mainly involves combining existing parts without substantial material transformation. Now who does process planning? So traditionally, process planning is performed by manufacturing engineers. These professionals possess expertise in manufacturing process and can interpret engineering drawings. So using their knowledge and experience, they determine the logical sequence of operation required to manufacture a product. Certain specialized tasks such as tool design are often delegated to experts in these areas. So what are the skills required for a process planner? So an effective process planner must possess several important skills. First, they should understand the engineering drawings, material specifications, tolerances and functional requirements. Second, they must have extensive knowledge of machine tools, cutting tools and their capabilities. Third, they should understand the interactions among product design, manufacturing process, quality requirements and production cost. So effective collaboration with design, quality and procurement teams are also very much essential in developing a process planning. Now this flowchart shows the process planning steps, where it involves the design, interpretation and process sequence. The first step in process planning is interpreting design drawings. Here we identify materials, dimensions, the tolerances and specifications. The second step is establishing the process sequence. So this sequence involves determining all the manufacturing operations required and arranging them in an optimal order to maximize productivity and product quality. So the third step is equipment selection. So process planners initially attempt to utilize existing equipment available in the factory. If existing facilities are inadequate, so alternatives include outsourcing the components or investing in new equipments. Tooling requirements such as dies, molds, fixtures and gauges are also identified. So special tooling is designed by tool designers and fabricating in the tool room. So coming to the method analysis, so the method analysis focus on improving operational efficiency. This includes optimizing the worker movements, workplace layout, tool placement and material handling systems. For manual operations, clear procedures are established for assembly, loading and unloading activities. So the objective is to reduce unnecessary motion, improve ergonomics and increase productivity. So coming to the work standards establish the performance benchmarks. So time standards are developed to determine cycle times for individual operations and the tool production time. So in machining operations, appropriate cutting tools and cutting parameters such as speed, feed and depth of cut are selected to achieve optimum productivity and quality. Then comes the cost consideration and continuous improvement. So cost evaluation is a critical part of the process planning. So material cost, tooling expenses, labor cost and equipment costs are all analyzed to achieve an economical process without compromising the quality of the product. So continuous improvement is also very much important. Feedback from production is collected, inefficiencies are identified and process plans are updated whenever new technologies or improved methods become available. Right, now coming to the factors influencing the process selection. Several factors influence the selection of the manufacturing process. So they include the shape and size requirements of the products, dimensional tolerances, desired surface finish, annual production volume and material properties. So choosing the correct process ensures both technical feasibility and economical viability. So material selection depends on several criteria including strength, fatigue resistance, hardness, thermal and electrical properties, reliability, durability and environmental resistance. So the compatibility with other materials, manufacturability, availability and cost are also being considered. So proper material selection directly affects the product performance, lifespan and overall production cost. So in conclusion, to summarize, the process planning serves as the link between product design and manufacturing execution. So a systematic process plan helps improve productivity, reduce cost, maintain quality and ensure efficient utilization of resources. So understanding these fundamentals is very much essential for every manufacturing engineers. So with this we will wind up this session. We will continue with the next session. Thank you.